If you're working with me, then you can. If not, then don't worry about it. So on I to the 212th, it's using the powers of I, and so the pattern is I to the 0, I to the 1, I squared, and I cubed. I to the 0, well, anything to the 0 power other than 0 is 1. Something to the first power is just itself. I squared, well, first off, it's important that you know what I is. I is the square root of negative 1. So when you square that, the square root of negative 1 squared, it's negative 1. So that's just negative 1. And then I cubed is just taking I squared and multiplying it times another I. So negative 1 times I is negative I. The idea is that this is a pattern. And so when you, a pattern of 4, so whenever you have this power, if I were to divide 4 out of 212, whatever the remainder is, it corresponds to these terms right here. So 4 goes into 212. Well, 4 does not go into 2, but 4 goes into 21 5 times. And 4 times 5 is 20. Subtract, I'm left with 1. Bring down the 2. 4 goes into 12 3 times evenly, which means the remainder is 0. So that means that I to the 212 equals I to the 0, which is 1. And so my answer is 1. Kelsey, you can get the door for Chloe so Cameron doesn't have to whenever she comes back. Okay. All right, number 2. We're supposed to simplify. What's up? That's fine. Yeah.
How many classes you guys need to graduate? 23? Is it 23?
I think so. All right. So we simplify. We get 3 plus 6i. This is minus. It is not multiplication, so don't turn this into multiplication. And negative 1 times 2. What I mean is, like, this whole expression is going to be added and subtracted to this one, not like put parentheses around them and distribute them all. Negative 1 times negative 4i is a positive 4i. And then plus 5 minus I. So at this point, it's a matter of combining like terms. So the real numbers, 3, negative 2, and 5. 3 minus 2 is 1, and 1 plus 5 is 6. And then 6i plus 4i is 10i, and 10i minus 1i is 9i. Hey guys, feel free to correct me if I accidentally make a mistake. So, sorry, I guess I left that off the side of the page. Okay, so on number 3, I'm actually multiplying these two expressions out, so I need to distribute. So I've got, first off, 2 times 4 is 8. 2 times a negative 5i is negative 10i. Negative 3i times 4 is a negative 12i. And negative 3i times negative 5i is a positive 15i squared. But as long as you remember that I squared is negative 1, then that is just a negative 15. Alright, so we need to combine like terms. 8 minus 15 is a negative 7, and that is a negative 22i. Okay, on number 4. Now this says 2i times 3 minus 5i squared. I have a lot of people that will try and do this. I have a lot of people that will try to distribute that before they square, and you cannot do that. You have to square the term first. If I were to say 3 times 2 plus 4 squared, 2 plus 4 is 6, and 6 squared is 36. So this is 3 times 36. If you were to distribute it, you would say that's 6 plus 12 squared, which is 18 squared, and those are definitely not the same thing, okay? So you cannot distribute before you apply the power. So it is 2i times 3 minus 5i times 3 minus 5i, which is what it means to square something. And then plus, we'll go ahead and distribute. 6 minus 12i. Okay, you can distribute the 2i to one of the terms before you multiply, but it's just however you want to do it. So you could distribute 2i to this and then multiply them, or you can multiply these out and then distribute 2i, which is what I'm going to do. We've got 9 minus 15i minus 15i, positive 25i squared, which makes it a negative 25. And then 9 minus 15i minus 15i. The 9 minus 25 combines. So I've got 2i times 9 minus 25 is negative 16, and that's negative 30i. We're just adding. No. Put them on the window ledge, and at the end of the period, if you remember it, then you can go get them. Openable? Yeah, if you break it. So I distribute the 2i. 2i times negative 16 is a negative 32i, and 2i times negative 30i is a negative 60i squared, which makes it positive 60, plus 6 minus 12i, so that is 66, and that is negative 44i. Okay. Number 5. I actually added 65 on here because of these problems. I want you to know how to do these, but the way that they are, I don't particularly love how they work out. When you're trying to get rid of an imaginary number in the denominator, you need to multiply by the... do you know how to lock the door? Does anybody? You know? The tab on the side? Yeah. Okay, you got to multiply by the conjugate of the denominator. So 6 minus 6i, 6 plus 6i. Now, if you want to, you could have divided everything in here by a 2, because 10, 10, 6, and 6 are all divisible by 2. But if you don't think about it, it's fine. So we multiply it out. So I've got 10 times 6, which is 60. 10 times 6i, which is 60i. 10i times 6, which is 60i. And 10i times 6i, which is a positive 60i, squared, which is a negative 60. And then in the denominator, I've got 6 times 6, which is 36. 6 times 6i, which is 36i. Negative 6i times 6, which is negative 36i. And negative 6i times positive 6i, which is a negative 36i squared, which makes it positive 36. So in the numerator and denominator, things actually cancel out and simplify. In the numerator, both the 60s cancel out. So, without the imaginary number, so that becomes 120i over, and in the denominator, the 36i's cancel out, leaving me with 72. And they both divide by, so 24. 24 times 5, let me check it right quick. It's 120, yeah. So that is 5i, and then 24 goes into 72 3 times. Now, if you needed to, you could break it up and just say, and start canceling. Especially if it was a non-calculator question, but that's what I would simplify it down to. Okay, number 6. Again, I need to multiply by the conjugate of the denominator. So I'm going to multiply top and bottom by negative 3 plus 9i. Okay, in the numerator, I get negative 27 plus 81i plus 9i, and then minus 27i squared, which makes it plus 27. In the denominator, I get 9 minus 27i plus 27i minus 81i squared, which makes it plus 81. So my numerator, the 27's cancel out, and I'm left with 90i. My denominator, the 27i's cancel out, and I'm left with 90. And 90 divided by 90 is 1, so I'm just left with I. Okay? On number 7, quadratic formula. First off, when you do the quadratic formula, everything has to be on the same side, so I'm going to subtract 84 over and have it equal to 0. So n equals negative b, which is negative 4 plus or minus the square root of b squared, which is 16 minus 4 times a, times c, which is negative 84 all over 2 times a. So when I'm working the quadratic formula, and this I would give you a calculator for, you figure out the inside first. Minus 4 times 3 times negative 84. And you get 1,024. So negative 4 plus or minus the square root of 1,024 all over 6. You should always first check to see if 1,000 or that number is a perfect square, and it is. So I get negative 4 plus or minus 32. The square root's gone, over 6. If you get a whole number, no imaginary, no rational, no radical, then you've got to simplify. So it is negative 4 plus 32 divided by 6, and negative 4 minus 32 divided by 6. Negative 4 plus 32, I don't know why I'm doing that, is 28. And 28 and 6 both divide by 2. So that makes that 14 thirds. And negative 4 minus 32 is a negative 36, and negative 36 divided by 6 is a negative 6. So we've got 2 answers there. Okay, 14 thirds and negative 6. On number 8, everything is on the same side, everything is in order, so I'll just start solving. P equals negative b, but 12 is already negative, so positive 12, plus or minus the square root of b squared. Now, if you write negative 12 squared right here, and you write it like this, you're going to get it wrong if you type it in like that. A real number squared is always positive. So I would either write in just 12 squared, or I would write in negative 12 parentheses squared, or I would write in positive 144, but that should never be negative. Minus 4 times a times c, all over 2 times a. Okay, and then I simplify. 12 plus and minus 64. 144 minus 64 is 80. So I get, 80 as a perfect square. You should definitely check to see if anything divides out of it. I mean, I know 4 does, but I think more. In fact, if you divide it by 4, you notice that it's 20, which means it's also divisible by 4, which means 80 is divisible by 16 5 times, and 5 is prime, so I know I'm done. So, if this is actually 16 times 5, then that means that this is 12 plus or minus 4 square roots of 5 all over 16, which simplifies by 4. That goes into it 3 times, that goes into it 1 time, and that goes into it 4 times. So my final answer is 3 plus or minus the square root of 5 all over 4. Okay. Number 9. Number 9, everything is on the right side, or on the left side, the correct side. And it's in order, so let's just go ahead and go. X equals negative b, so negative 3 is positive 3, plus or minus the square root of b squared. I'm going to go ahead and put positive 9 minus 4 times a, which is 4 times c, which is 8 all over 2 times 4. So I've got 9 minus 16 times 8, or 4 times 4 times 8. And that gives me negative 119. So 3 plus or minus the square root of negative 119 all over 8. Well, first off, if you have a negative underneath the square root, you have to automatically make that an I. So I'm going to go ahead and put an I again. Now, as far as the square root of 119 goes, if you're unsure, you should check. So 119, if you think about your list of perfect squares, it is between 100 and 121. I know it doesn't divide by 100, 81, 64, 49. I know it doesn't divide by 36, but you should check if you're unsure. You know, if you're unsure, just go through and check. I know it's not even, so it doesn't divide by anything that's even. Anyway, what you find out is that it's prime, and so it's just 119i. And that's your final answer. Okay? On number 10, you've got everything on the same side. It's in the order, so let's just fill it out. X equals negative b, which is a, plus or minus square root of b squared, which is 64, minus 4 times a times c, all over 2 times a. So I've got 64 minus 4 times 7 times 4, and that is negative 48. So I've got 8 plus and minus the square root of negative 48 all over 14. Now, you need to be careful that you don't simplify these two without simplifying this root out. And what you can't do is divide this, and this all by 2 or something like that, because that's inside a square root. Only the number outside the square root can be simplified. Now, I have a lot of people that be like 48, well, it divides by 4, and then call it good. But 12 is also divisible by 4, which is why you should always check, starting from the largest that could be possible, and then dividing them out. 48 divides by 16 3 times. So I think of this as negative 16 times 3. And so I've got 8 plus and minus. The square root of 16 is 4. The negative is an I, and the 3 stays on the inside, and I'm left with 14 in the denominator. And then I notice that 8, 4, and 14 are all even, which means I can divide them all by 2. So if I divide each of these by 2, I'm left with 4 plus and minus 2 square roots of 3i all over 7. Okay. 11 through 14 are just a bunch of multiplication. So let's just multiply them out real quick. Make sure you got the right answer. Okay. Oh. That right there is 12x squared. By 12 I mean 8. I was looking at the 3. And then that is negative 10x. That is positive 12x, although I think on the paper there I put negative. And then that is negative 15, which makes that 8x squared plus 2x minus 15. On this one, I need to distribute the 3x plus 1. So that is a 6x cubed, a negative 9x squared, a positive 12x, a positive 2x squared, a negative 3x, and a positive 4, which adds up to 6x cubed minus 7x squared plus 9x plus 4. Number 13. To square something means to multiply it by itself, so you need to remember that you have to expand this to 2x plus 3 times itself. So that is 4x squared plus 6x plus 6x plus 9, which means 4x squared plus 12x plus 9. And there's my answer. On 14, you got extra variables, so you need to distribute, and when you multiply, you just add the powers like normal. So 3 times 2 is 6, x squared times x is x cubed, and y times y is y squared. 3 times 4 is 12, x squared times x is x cubed, and then there's just one y. And then 3 times negative 3 is negative 9, x squared y, x cubed, y squared, x cubed, y, x squared, y. None of those have the same powers completely, which means I can't combine them. So that is my final answer. Alright, on 15. So on 15, I'm supposed to graph the function and determine all this information about it. So I'm just going to kind of go in order from the inside. Minus 1 on the inside means I'm going to go to the right 1. 2 on the outside means it's a vertical stretch by a factor of 2. A negative on the outside means I'm going to reflect over the x-axis. And plus 4 means I'm going to go up 4. So when you think about the parabola in general, starting at 0, 0, it's going to go to the right one. Then it's going to be vertically stretched by a factor of 2, so it's going to get skinnier. And then it's going to flip over, and then it's going to go up 4. So, in general, it's going to look like that. But let's actually sketch that. I'm going to go to the right one, up 4, 1, 2, 3, 4, and then just make sure I point down. Okay? Now, the pattern for parabolas is 1, 1, 2, 4, and 3, 9, because 3 squared is 9, 2 squared is 4, and 1 squared is 1. In this case, because of the negative in the front, we're going to go to the right 1 and down 1 times 2 because it's a vertical stretch, to the right 2 and down 4 times 2, and to the right 3 down 9 times 2. So I'm going to go to the right 1 and go down 2 on both sides. I'm going to go to the right 2 and go down 8, which was being at negative 4. And I'm definitely not going to be able to see over 3 and down 18, so I just connect, and there's my parabola. Okay? As far as domain and range goes, domain is all possible x values that this is defined on, and this is going to keep on going down and down on both sides, but it's going out, so it's going to the left and the right. So domain is all real numbers or negative infinity to positive infinity, however you want to say it. And then the range is the lowest it goes is negative infinity, and the highest it goes is 4. I have a lot of people that are saying if it's negative infinity, they're saying like 4 to negative infinity. You have to go low number to high number. Y'all hear that? I'm grading your 4.1 homeworks on those radicals, and a lot of you are getting your domain and range backwards. It always has to be low number to high number. So if you write 4 to negative infinity, I'm going to count off half credit, okay? Because it has to go low to high number. Alright? So always think the lowest number needs to go first. Now, extrema means max and min. Extreme values, right? So the highest this function goes is to the vertex right here. The vertex is the point 1, 4, so I would say it's a max because it's the highest it goes at the point 1, 4. And there's no minimum value because it keeps on going down negative infinity, so you just don't have a minimum. Increasing and decreasing. If you were to graph this on your calculator, which we're not doing, but if you were to graph it on the calculator, then it would start from down here, and then it would be going in this direction, which means it would be increasing, right? But then, as it reached the vertex, it's going to turn around, and now it's going to start decreasing. That's exactly what we're doing. But increasing and decreasing, I'm talking about where. So, negative infinity, positive infinity. The function is going to be increasing all the way from negative infinity until I reach 1. So I would say it's increasing from negative infinity to 1 on the x values. And then I would say it is decreasing from 1 to positive infinity. Okay? I know I am increasing from negative infinity up to 4, but the question is, where are you increasing and decreasing? And you're increasing on intervals of x. So if you just break it up on the x-axis, then you're good. Okay, in behavior. In behavior is basically what are you doing on the ends? So as you go to negative infinity, where's your function going? This is asking the limit as x approaches negative infinity of y is, meaning what is the value that y is approaching? As x goes in this direction, the function is going down to negative infinity, so it is negative infinity. And the limit as x approaches positive infinity of y, so as I go to the right, the function is also going to negative infinity, so my answer is negative infinity. And on quadratics, they should always be the same. So if they're pointing up, they're both positive. If it's pointing down, they're both negative. On 16, describing the transformations, I've got plus 4 means go to the left 4. 1/2 is a vertical compression by a factor of 1/2. And minus 7 means go down 7. So I'm going to go left 4 and down 7. 1, 2, 3, 4, down 7. and there's my vertex. Now, it's positive on the inside, so that does, or on the outside, so that does mean that the function is going up instead of down. So I'm going to go ahead and use my pattern to figure this out. In parabolas, I go over 1 up 1, over 2 up 4, and over 3 up 9. But because of the 1/2 of vertical compression, I got to multiply the verticals by 1/2, which makes it going up 0.5, 2, and 4.5, which means I could probably see another one. 4 and 16 times 1/2, that's 8. So let's see. Over 1, only up 1/2 on both sides. Over 2, up 2. Over 3, up 4.5, so 4.5. And then over 4 and up 8. So 8 from -7 puts me at 1. I can see another one on there, so I'm going to go ahead and do it. Over 5, up 25, but half of that is 12.5. So if I go over 5 and up 12.5, 12.5 from -7 is 5.5. And there we go. Okay. So, domain and range. Well, technically for every parabola, if it's fully defined everywhere, it has a domain of all real numbers. It goes to the left, it goes to the right, and it never stops. So my domain is all real numbers. My range is low to high. The lowest it goes is -7, and the highest it goes is up to infinity. So my range is -7 to infinity. Extrema, well, the vertex is the low point on the graph, so it is a minimum, or a min, at the point, I don't know why I did that, -4, -7. My function starts off decreasing. If you look at the way the numbers go, or the way the parabola goes, it would start from the left and then go down. So I'm decreasing from -infinity until -4. And then after that, the function is increasing from -4 to positive infinity. Okay? In behavior, basically where's the function going, and on both sides it's going up. So I have the limit as x goes to -infinity of y, and the limit as x goes to positive infinity of y. So as x goes left and go to the right, in general, the function is going up. So they're with positive infinity. Alright, numbers 17, 18, and 19 are all radicals. So, on number 17, +5 on the inside means I'm going to go left 5. 2 on the outside means it's a vertical stretch by a factor of 2. And +2 means I'm going to go up 2. So I'm going to go left 5 up 2. And then I'm going to do the vertical stretch. Now, on a radical, the pattern is 1, 1, 4, 2, and 9, 3. Not 2, 4, 3, 9, because the square root of 4 is 2 and the square root of 9 is 3. But it's a vertical stretch by a factor of 2, which means I need to multiply all the heights by the verticals by 2. So I'm going to go over 1 and up 2, over 4 from -5, which is -1, and up 4, and over 9 from -5 is 4, and up 6. And I connect and find my domain and range. So if you think about domain and range as like domain is left to right, -infinity to positive infinity, and you just think, where is it defined? Yeah? It doesn't start being defined until here. So -5 to positive infinity is my domain. And then range is a vertical, y values. So if you think about it as negative infinity up to positive infinity, and it doesn't start being defined until here, which is at 2, so we go from 2 up to positive infinity. Okay. Now on number 18, I've got negative 1/3 x and then negative times the square root of 1/3 x and then plus 5. So the 1/3 on the inside is a horizontal stretch by a factor of 3 because you have to flip the fraction on the inside. And the negative on the outside is a reflection over the x, and then plus 5 means I'm going to go up 5. So if I take my regular radical, I horizontally stretch it by a factor of 3, it's going to be a lot longer. I flip it over, it's going to do this, and then I go up 5. Then it's going to look like that. That's going to be my final graph, something like that. Okay? So, as far as vertex goes, I know I just need to go up 5 from 0, 0. Puts me up here. And then I'm going to use the pattern. I know I'm going to go to the right and down. 1, 1, 4, 2, 9, 3. I go down because of the negative on the outside. And then horizontal stretch by a factor of 3 means I multiplied these by 3. So I should go to the right 3 and down 1. So to the right 3 and down 1, pay attention to the scale. So I should be at the point 3, 4. And then I'm going to go to the right 12 and down 2. So 12 is right here. And then down 2 from 5 is 3. And that's all I'm going to be able to see. So my graph should look like that. Okay? Domain in range. Domain is left to right. So negative infinity to positive infinity. And it doesn't start being defined until 0. So my domain is 0 to infinity. And my range is low to high. So if I think about it as negative infinity, positive infinity, it doesn't, or it stops being defined right here, up here at 5. So if I think about it, it goes from negative infinity, low to high, up to 5. Okay. On number 19, is number 19 posted up there or not? No, neither of these pages are? Okay. Would someone go tape this side up? Go tape. Okay. Just put it in the middle and then I'll put this one above or below it. Okay. Number 19. And I need you all to listen to this, okay? Because I'm sure that you corrected it by now, but I had a lot of people doing this on the homework. Is everyone looking up here? Okay. You know what you can't do? You can't do this. Put parentheses around it and then distribute the negative 2. That is in no way equivalent to what we started with. The point is that it's negative 2x plus 8, right? I agree that I want you to have parentheses and I want negative 2 to be outside of it, but you got to rewrite it. You don't distribute, you factor out, okay? So you should write this as a negative 2 with a parenthesis and then divide out the negative 2. Negative 2x divided by negative 2 is x. 8 divided by negative 2 is a negative 4. So don't just put your parentheses in there. No. Don't. Okay. You need to factor the negative 2 out from both terms, which means dividing, okay? In some situations they were kind of weird, but it just means dividing, okay? So, this right here can be rewritten as the square root of negative 2 times x minus 4 and then minus 4. So my transformations are to the right 2, and by 2 I mean 4. The 2 on the inside is a horizontal compression by a factor of 1/2. Remember, you got to flip it on the inside. And negative on the inside means I'm going to reflect not over the x, over the y. And minus 4 means I'm going to go down 4. So I'm going to kind of sketch what that's going to look like. I start with a normal radical. I go to the right 4. Let me just do these in different colors. So I go to the right 4, so now I look like that. And then I have a horizontal compression by a factor of 1/2, which just means it happens faster. That doesn't change location though. Reflecting over the y, oh, I'm a goober. That has to go first. I'm just kidding. Alright, I shall start over. You have to reflect over the y first. If there's a reflection over the y, it has to be done first. Now, if you just went to the right 4 and down 4 and just knew that because of the reflection over the y, you should point in that direction, I'm fine with that because that ends up in the same spot. But if you're actually like thinking about the order, it should be reflecting first and then go right 4 and then go down 4. So your final answer should be some radical over here. So if you go right 4 and down 4, and just know that you probably should point that way, then you'll be okay. So I know I'm going to go to the left, so that means my pattern is going this way, 1, 1, 4, 2, 9, 3. But I have a horizontal compression by a factor of 1/2. So I multiply the horizontals by 1/2, which means I'm going to go to the right 1/2 and up 1. I'm going to go to the right 2 and up 2. I'm going to go to the right 4.5 and up 3. 1, 2, 4.5 and up 3. Which means I can see more, so I'm going to do more. It would be 1, 2, 3, 4, so 16 and up 4. Yeah, I can square 16. And then 25 and up 5. So if I multiply that by 1/2, I get 8. So I'm going to go to the left 8 and up 4. Which will say negative 4, 0. And if I multiply that by 1/2, I get 12.5. So I'm going to go left 12.5 and go up 5. 12.5 from 4 is 8.5. So 8.5 and up to there. I don't even know if y'all could see those. Could they see those? Was anyone watching that? They could see them? Could you see these when I was writing them? Okay, good. Whew, okay. Now, my expectation is at least these points, the vertex and then over these 3. I couldn't count off if you didn't do those, so it's okay if you don't, if you're wary about them. Okay, connect, and then domain and range. So domain is left to right, negative infinity, positive infinity, and it stops being defined at positive 4 on the x-axis. So my domain is negative infinity to 4, and my range is low to high, negative infinity to positive infinity, and it doesn't start being defined until negative 4. So negative 4 up to positive infinity. Okay. On 20 and 21, which I did say you could use calculator on, we got to find out if it's arithmetic, and if it is, then we're going to answer all this information about it. So you need to see if there's a common difference. What you can always do is do the the second term minus the first, the third term minus the second, the fourth term minus the third, and if you get the same thing, you're good. Or you can just say the difference between here, I can tell, is that I'm going down 10, and another down 10, which means it is arithmetic. Explicit formula. So in general, the explicit formula is x sub n equals x sub 1 plus the common difference times n minus 1, and all you gotta fill in is the first term and the common difference. Okay, so x sub n equals x sub 1, which is negative 2, plus the common difference. You could put plus negative 10 if you want. I'm going to go ahead and put minus 10, but you could say plus negative 10, times n minus 1. And there's my formula. That's all I got to write down. Okay? The recursive is x sub n equals x sub n minus 1. Like that. Okay. And then you have to tell me what the first term is. If you don't tell me what the first term is, then there's no reason for me to start at that particular number. Because all this says, oh gosh, I didn't even finish the formula. X sub n equals x sub n minus 1 plus the common difference. And then tell me what the first term is. If you just said, in general, we just subtract 10, then what's to stop me from starting at 25? I mean, there's nothing that tells me I have to start at negative 2. So you have to tell me what the first term is. So x sub n equals x sub n minus 1 minus 10. This has to be a subscript, and that has to be in line with the x, comma, the first term is negative 2. So you just have to tell me that. Now the 52nd term, I'm actually going to fill in 52 right here and then evaluate it. You could just type it in the calculator, so just whatever you want. X sub 52 is negative 2 minus 10 times n is 52 minus 1, which is 51. You cannot combine negative 2 and negative 10 before you multiply by 51. You have to, because negative 10 is being multiplied and negative 2 is not. Don't be silly. And I suggest you just type it in exactly how you see it so that you don't make a mistake. Negative 512. And then on 21, I noticed that between 172 and 372, it is negative 200. And if I subtract, if I say 28 minus 200, then I get negative 172. So the common difference is negative 200, which means the explicit formula is x sub n equals the first term minus the common, or plus the common difference. I'm going to go ahead and say plus and minus, and then n minus 1. The recursive formula is x sub n equals x sub n minus 1 minus 200, comma, the first term is 28, and the 52nd term equals 28 minus 200 times 52 minus 1, or 51, which means 28 minus 200 times 51, and it gives me 10,172 negative. And there you go.